Good morning. This is Subhashish Chandra, Assistant Professor, Government Institute of Forensic Science, Nagpur. Today we are going to talk about basic semiconductor devices and applications, and in that we will be looking into the semiconductors and PN junction diodes. Now, a semiconductor is basically a group 4 element, the two famous ones being germanium and silicon. They have four electrons in the valence shells which are shared by the neighboring atoms. If we look at the band diagram of an intrinsic semiconductor, we find out that there is a band gap Eg, which is about 1.1 eV for silicon, and it has two bands, the conduction band and the valence band. The conduction band in normal condition is always empty, whereas the valence band is always full. If you give a little bit of energy to the uh, semiconductor, electrons may travel the band gap and be transferred from valence band to the conduction band. In that case, if electrons travel from valence band to the conduction band, two holes are created in the valence band. So, such an intrinsic semiconductor does not provide enough conductivity. For that, we require to dope the material with either a p-type material or an n-type material. Let's look into that. In case of a p-type material, a group 3 element is doped so that we find out that 3 electrons share and form covalent bonds, whereas one of the bond is not completed. So what it does is it creates a hole over there. So in the band diagram you can see that an additional level is created. It is called the acceptor level, through which electrons are donated and holes are created. So p-type semiconductor is basically a positive type semiconductor. The next is the n-type semiconductor, in which a group 5 element is used, which has 5 valence electrons. So 4 bonds are formed and 1 free electron is donated. So since it donates electrons, it is called the donor level, and in the last case it was the acceptor levels. Then if you join them and a metallurgical junction is created, that junction is called the PN junction, and in the PN junction the P type have holes and the N type have electrons, and in the center there are no free charges, and hence it is called the depletion layer, and in this depletion layer immobile ions are present. This is the symbol for the PN junction, and when you give no bias, that is when you don't provide any external electricity to it, no charge carriers travel from the P to N type or from N type to P type. So there is no current across the junction. So if you require a current across the junction, you have to do forward biasing, that is provide positive voltage to the P type and negative voltage to the N type. In that case, the holes can travel to the N region and the electrons can travel to the P region, which reduces the potential barrier, and this is called the forward biasing. Another way is the reverse biasing, in which the opposite polarities are connected, as was in the last case. Now in this case, there is no current due to the majority charge carriers, but there is a current due to the minority charge carriers, which is in microamperes. This is the current scenario. For forward bias, there is no current in the beginning, but once it achieves the knee voltage, the current increases exponentially. In case of the reverse bias, there is an initial current and then the current saturates, that is, even if you increase the voltage, the current remains the same. That saturation is called current is called the reverse saturation current I0, and after a certain voltage called the breakdown voltage, the junction breaks down and there is a sudden surge of current even if you don't increase much voltage. So that was all about PN junction and semiconductors. Thank you.